Hey guys, so you've made it to Friday. This is going to be our very first recorded lesson. The way I'll do these typically is just like this. We'll start with a little bit of me talking about the lesson with the camera on me, and then I will switch it to pretty much you're just watching my hands as I work through the problem. Today we're going to be on page 7 in your math book, and we're going to be talking about place value and patterns. And I'm going to introduce to you something that's helped kids in the past. I like to call it big guy, little guy. It's somewhat helpful if we do it like that. So it'll make more sense when you see it. It sounds weird now. And I almost forgot to mention, I always like to start the lessons with a dad joke at some point. They're usually pretty crummy. That's kind of the point. So I hope you enjoy or don't enjoy or enjoy not enjoying. A couple years ago, I went to a concert. It was a really good deal. It was only 45 cents. It was 50 Cent playing with Nickelback. So this sheds a little light on what I was talking about with the big guy, little guy concept. Today we're going to be given a number, and it's sort of like a mystery. We need to figure out what the other number is in the set. So, for example, they might say that 6 is 1/10 of another number. So when I hear 6 is 1/10, and we look over here, this thing is made up of 10 parts. This part is made up of one of those 10 parts. So this is the little guy. It's 1/10 the size of this guy. This guy's the big guy because he's 10 times greater than this. So if I say what number is, or if I say 6 is 1/10 of what number, that means the 6 is the little guy. It's the 1/10. Did you hear how I said that? 6 is 1/10 of another number. So what I would do is I would just write a little 6 here to give myself a reminder of that. And then I would know that the other number is 10 times greater than that. So what do you do with that? You take that little number, 6, and you take it times 10 to get your greater number, which would be 60. So the little guy would be 6, and the big guy would be 60. The reverse of that is also true. If I gave you the number 60, and I said 60 is 10 times as much as, I'm now telling you that 60 is 10 times. So 60 is the big guy. We need to figure out what the little guy. So 60 is 10 times what number? So give yourself a little reminder. So if the big guy is 60, what would be 1/10 of that 60? Well, that's like dividing by 10. So you say, 60 divided by 10 would be 6. So the little guy would be 6 in that scenario. Let's do some on the sheet. I'm looking at page 7. All right, page 7, number 1, we'll look at a couple of the odd problems here. I got my big guy, little guy here just for reference, kind of keep it straight in my head as I'm doing this. It says 500 is 10 times as much as. So it's telling me 500 is 10 times. So that means 500 is the big guy. And we want to know what the little guy is. So we want to know what is 1/10 of 500. Another way of saying what's 1/10 of it, if you're not familiar with fractions so well yet, is we're going to divide by 10. Now let me show you a little trick. When you're dividing by 10, all whole numbers always have a decimal to the right. So if you don't see that decimal there, just know it's always there. Now if we're going to divide it by 10, it's going to make it a lesser number. And you hear lesser starts with a L. So that will remind you, I need to move this decimal to the left. Now, since we're dividing by 10, another way to think about this is 10 has 1 0, so we're just going to move it one place to the left. Now, we're only going to be dealing with 10s today. If it were 100 that I was dividing by, 100 has 2 zeros, so I would move it 2 places. But we just want to know what 1/10 of it is, which, like I said, is like dividing by 10. So I'm just going to move that decimal one place to the left, and you can see it now sits right there. So 1/10 of 500 would be that. So 500 is 10 times as much as 50. And if you don't want to keep that 0 and that decimal there, you don't have to. That's a personal choice. All right, moving on to number 3. Again, have the big guy, little guy for reference. It says 900 is 1/10 of another number. So remember, this is 10 times greater than this, and the small guy is 1/10 the size of that. So this is 10 times greater, and this is 1/10 of. Now, it tells me 900 is 1/10, so I can just remember that 900 in this case is the little guy. So we want to find out what's the big guy. We need to make it greater times 10. Now in the previous problem, I mentioned that all whole numbers always have a decimal to the right, even if it's not already there. It's a good practice to get into just putting it there. Now, when we divided to make it smaller by 1/10, we moved it one place to the left. So if I want to make the number greater to find out what the big guy is, I'm going to move that decimal in the opposite direction. I'm going to move it one place to the right. And then we're going to go ahead and fill this empty space with a 0 that we just created. And we can see that the big guy in this case is 9,000. Now, as we move on to these table problems, these tend to be a little confusing for kids. So when you go and you click on your assignment that you're going to be doing for me, you'll notice I did not put it in a table form just because it tends to cause some issues. So again, we're going to do the odds. I'm looking at number 5. So just remember, we're always going back to this original number, and then we're doing whatever it says at the top of the column. So it wants to know what is 10 times as much as 10. So for me, remember, get those decimals in there on your whole number. It's going to be very helpful, especially when we start getting into numbers that already have decimals present. Now we want to know what's 10 times as much as 10. So to make it 10 times greater, remember, we're going to move in the direction of the right. We're going to move to the right. And we're just going to be moving it one time to the right and putting in our new decimal. So I should have probably done that here. You'll remember the decimal was originally right there. So I'm just sliding it over, putting it in its new home, and now 10 has become 10 times greater. It's 100. Now back to that original number. Sorry about doing that. That was my bad. So back to that original 10. So I'm going to start with the 10. I'm going to put my decimal in. Now we want to know what is 1/10 of it. If I only get 1/10 of a pizza, I'm getting less than the whole pizza. So we're going to make it less. So I'm going to move this decimal one place to the left to make it 1/10 its current value. So it's going to slide right here. Here's its new home. So your answer for this one would be 1.0. Let's try that again for number 7. For number 7, we're again starting with 800. So just remember that decimal begins there. We want to make it 10 times greater. If we're making it greater, we're moving to the right. So you start with your 800. The decimal lives here. We're going to move it one place to the right, put it in its new home. It's 8,000. Go back to that original 800. Now we're going to make it 1/10 of. 1/10 of is making it less, so we're going to move to the left. Start with that 800. We know the decimal lives to the right. We're going to move one place to the left, and we've created our new number, 80. If that 0 bothers you, you can erase it or just leave it like that. All right, so I didn't include any of these on your assignment. We'll kind of think of this as like an added bonus. I wanted you just to focus on the concept of making something 10 times greater and moving it one place to the right, or making it 1/10 the value of and moving it to the left one time. But for these, let's go ahead and just kind of extend our thinking out. In this case, we have 200 is a certain amount of times as much as 2. So in other words, we're starting with 2 and it's becoming 200. That's one way we can look at it. So how is this 2 becoming 200? Now, if we remember the decimals are to the right, how many moves to the right would this decimal have to go to become 200? Well, if it started there and it goes 1, 2. So we're going to move it 2 places. 1, 2, put the new home, and we're going to backfill our zeros in. So what that tells me is that in order for 2 to become 200, I had to move it 2 places to the right. Now, when I moved it 1 place to the right, that made it 10 times greater, 1, 0. So if I'm going to make it 100 times greater, I'm going to move it 2 times to the right. So 200 is 100 times as much as 2. And let's address this one more time with number 15. Again, 700,000 is a certain amount of times, so 10, 100, 1,000, 10,000 times as much as 700. We need to unlock and find out how many times greater, or in other words, what we have to multiply this times to get it to be this. Now, if you put in your decimals where they belong, to the right, you'll see that it started here, which was just past these 2 zeros, and then it moved 1, 2, 3 places to the right. So it moved 1, 2, 3 places to the right. Now, what base 10 number has 3 zeros to the right? You guessed it. That would be 1,000. So if you take 700 times 1,000, that means I move it 3 places to the right. and you get 700,000. You can see they're the same. All right, that concludes lesson 1.1, place value in patterns. I will see you live later.